All right, we are back with more Factorio. Here we go. I am Pax, and we are continuing here with the playthrough of space exploration. And yes, last time we were preparing to build, well, to build more of these antimatter reactors. So we built 4 of them now, helping us provide power to give, or, oh my god, give me a break, to the gate. And so yeah, we have like a bit over 100 gigawatts if we also add in our spaceship here for giving us 7 extra, and I guess the other one gives us 1 more, so but yeah, so I also added these little combinator overrides to override the power plants just in case because I don't want them to accidentally let the gate turn off, but we'll deal with that when the time comes. Actually, this whole thing is missing, it seems. Oops. Connect the water. Should be connected. Yep. Wow. Okay, but anyway, that's fine. Not that big of a deal. Alright, so, well, the plan then is to first, well, let's talk about what the gate is and what the puzzle is and how to actually solve the gate puzzle. So we can see that the gate, of course, is surrounded by the constellations, and we can move the gate and have it rotate and then stop it. And the point is then we can align up a symbol with one of these movable components and press R, and it will get inserted into the slot. And this is actually specifying one of the coordinates. And the goal of the game is to specify a particular coordinate to the gate and see what happens when the gate opens. So, well, I just decided here now, let's just throw in some kind of random coordinate. I want to turn these on. Let's get these going because it's hard to sustain the 90 gigawatts it gets all the time, and I don't want it to accidentally run out of steam for a second to turn the gate off. But yeah, so you can just jam in some random coordinates and see what happens. The gate opens. Of course, we built the other 4-dimensional anchors, and because we have sufficient thermal fluid. It's hard to tell how much this uses. It actually doesn't seem like it uses that much, really, but oh well. So the gate opens, and what happens? Something's coming through the portal. It's spiders. Oh my gosh, it's spiders. Well, okay. Well, that's probably a sign that we didn't press the right combination to close the gate, stop the biters from coming in. Okay, biters. Good job. I accidentally picked that up. My gosh, almost lost some laser charts. So, but then we have a number here, and it is a distorted vector. So this is what the code we put in told the gate is one of these numbers. And so then, in a sense, the goal of the puzzle is then to read this anomaly ship log, and it repeats over and over this number here, negative 0.56682, 0.0272, etc. This is one of these vectors, and essentially, if you read this log carefully, what it's suggesting is that we teleported here using this number and crashed, I guess, with this ring. And so this was then the clue to how to get home. So we need to put in a code related to one of these standard vector number formats into the gate. And the code has to do with the temple puzzle and the constellations, of course. So, of course, we were running around the galaxy looking for planets, and some of them have the temples. So, geometric structure, we visited a couple of them, of course, and let's see, how many have we visited? I think about 30. So we can look at these flag symbols here, and there we go. Here are all the geometric structures we've actually visited. And I think it's about half of them. So we've visited about 30 of them. And then, of course, every time I went to visit one, I took a picture. So yes, we took pictures of the temples. So I have a solid library of the temples. And there are actually 2 puzzles in the temples that you need to solve to understand how the coordinate system for programming the gate works. And the first is the big circle, which has to do with the first clue, and then of course the second is the little triangles, which has to do with the second clue. And what I ended up doing was creating a little workspace over here in this program Inkscape, and the first thing I started trying was just putting the symbols down and then putting their neighbors next to them. And you will see that often they kind of clump together, and if you think about the neighbors of this symbol, then a nearby symbol will have similar neighbors, and you can lay them out, and eventually you realize that they are laid out onto a sphere. So you can kind of tell eventually with how it doesn't like quite fit like when you lay it out like this, but the things at the bottom kind of stretch over and have neighbors down here, and eventually it makes sense that this is actually just on a sphere. So that means then you can tell then that also the other clue for this is just that the star mapping coordinates are all 3-dimensional points, but if you look carefully, they all are vectors in 3 dimensions that have only a length of 1. So basically, if you square all the components of any of these coordinates, you realize that they're just points on a sphere. And so everything is on a sphere, and the kind of jigsaw puzzle from the temple tells you sort of the relative locations of all the constellations on the sphere. But it goes a little bit deeper, and I definitely needed some hints to figure this out, but it's not just a sphere, it's a particular shape, and there's a constant consistency to the pattern. So we did notice how a lot of pattern numbers had the same, a lot of constellations had the same set of numbers, but sometimes there's a negative sign, sometimes the numbers are permuted, and in fact, what the shape spells out is what's called a pentacus dodecahedron. So then all the faces of such a shape are triangles. They're almost equilateral triangles, but they're not quite. And then there are vertices given by these different points, and they're cyclic permutations. So essentially, like by doing all the combinations of these kind of sets of points and cycling them or making them plus and negative, you create a shape like this pentacus dodecahedron, and pretty, and then you can like just make it the size of a sphere, and every face is like essentially the same distance from the center, like a sphere. So the clue then requires you to understand that the first coordinate, or the first symbol, tells you the direction on this pentacus dodecahedron. And by sort of using some clues from the star mapping, as well as then clues about the neighbors of the symbols, you can really see exactly on where the pentacus dodecahedron, the constellations are, and then also pretty easily tell like exactly what their coordinates are because they have to be some combination of a certain set of numbers and in a certain order, and plus or minus. There are these cyclic permutations, and so you can figure it out where they are, but you can also figure out even more easily from the symbols. So like you can tell even here how like with the triangles exactly even the orientation of the different neighbors. So we have, and then of course after you look at these constellations for a long time, you end up naming them. And so basically here I have the constellation Longlegs, and So it's in this part of, it's one of these, this is the triangle that defines it. And so it has then, you know, on its flat edge, this neighbor, cool lambda. Then on its right neighbor on the right edge, it's emo3 and, you know, cash money down here. Then we got sly lambda and squiggles and alien E, left arm. So I ended up naming all the constellations, but you can see like pretty clearly in the diagram exactly what the triangles are that define the boundaries for each of the constellations. And so then the other part of the puzzle pyramid are the symbols down here. And so after you see these for a while, you realize that they kind of connect to each other like a jigsaw puzzle. So you'll see that like some of them pointing at each other and have the shapes of other shapes. And but then there's also all this symmetry. And so you actually, because the puzzle is actually symmetrical, so you don't actually need to see every face in the temple to realize that if you just reflect certain pieces or rotate them, then they'll fit in the puzzle like in a different location. So then ultimately the symbols down here give you sort of jigsaw puzzle that then forms a triangle. And so you can then kind of put together the full triangle based on all the faces, and then you get this triangle. And of course, the idea is that then the constellations that you discover end up fitting onto the triangle as well. And then this is the second part of the coordinate system, that the constellations correspond to the different triangles. But then what you'll notice as well is that the gate, there's only 60 temples, and there are only 60 faces to this dodecahedron. And so there are actually only 60 constellations, but you'll notice the gate has 64. So we counted them before, and there are actually 64 different constellations. And so if you figure out the 4 that are left over from the gate, it's pretty obvious like where they go and what they mean in a sense in this little piece of the puzzle. And so there's these 3 constellations that are basically like little arrows. And so these 3 belong at the extrema of the triangle. And then there's one more that goes right in the middle. So there's no temple that has these 4 constellations in them. And so these are then kind of the extra special constellations that aren't in the temples, but it's clear kind of what they mean. And in fact, the symbol in the middle ends up being like super useful and important because it means 0. So essentially then you can measure any of the star coordinates that you want by, in essence, just putting in the first coordinate the star constellation that you want. So Alien E here, I'll put in, I think, let's see, do I have Alien E? I thought so. So just to verify, like, you know, here's its coordinates as given by the star mapping, but I can put it in the first position, and then what we do is go fly around and look for the symbol that means 0 effectively. So there it is. So we want to just put this then in every slot, and then just stop the gate when the constellation goes to the slot. There you go. Okay. Here we go, here we go. Turn the gate. Put the symbol, inject the symbol. So we're cranking up on power, 50 gigs, but I think we'll do fine. We'll do fine. And so we go around and just put the symbol in. Yeah, one too far. Okay, almost done. Sort of, still 3 more, but okay. More than halfway done, I guess. So then, yes, this is what I've been doing. You do this a lot of times to try and figure out like what the heck's going on, and it's a, you know, kind of tough to find the symbol and put it in the right spot, and it takes a bit of time to do all the symbols like this. But once you know that this means 0, it really helps infer a few things about how the gate works. And I first definitely did not infer this. I wasted a lot of time exploring different options on the gate. And, well, it's still probably going to be biters, but we will get an exact measurement then of alien E from the gate. I call this a measurement when we activate it and get a number out. So there you go. This is the measurement we got. And just turn it off real quick before we get invaded by biters. But we can see then that, you know, essentially the coordinate system that we measured from star mapping is exactly the one that we get back from the gate, because we plugged in exactly the alien E. And if we put in any other number in any other position, we get something slightly different. And so then the first coordinate of the coordinate system is then defined by the Pentakis dodecahedron here, and this first slot is the first coordinate. And so then now for every extra coordinate, what we need to do is imagine that this triangle surrounding the first coordinate is this triangle. Okay, and so then the coordinate will fall somewhere on the face of the surface of the Pentakis dodecahedron, but then we can specify it more precisely by then specifying in the second position the next constellation that essentially is like the next digit in the number. So that then happens over and over, and every time you want to zoom in on the target destination, you can specify a coordinate that's a triangle based on this triangle system. And so then, like, once you specify the second coordinate, so say the second coordinate was what I call sun over here, then you would map again the same the big triangle onto this smaller triangle, zoom in again, and then try and figure out where inside of the smaller triangle would be the next coordinate. So you do this procedure kind of over and over. Zoom in to more and more precise of a number based on the coordinates. And if you infer the clue in the journal correctly, which I didn't do, I definitely tried to put in this number first. So I put this number in exactly, try to eventually figure it out based on this number. But if you read the text carefully, it really says that you came from here towards here. This was our target. And so actually the goal is to go back home, right? So we actually want to put in the number negative, so the negative version of this. So we actually flip all the positive digits, and then we want to figure out how to get back. And so if you have all the star coordinates, then basically you can just figure out which constellation is the closest to the negative version of this coordinate system that we used to get here. And if you're really maniacal, you could brute force by just once you know that this system is here and that you have the zeros, you can set them all to 0 and then one by one go through all 60 constellations, or 64, I mean, really, and figure out which is the closest every time. And then eventually zoom in on the answer. But if you're a little more careful, you don't have to necessarily brute force it. And so here I actually built some Python code to help figure out like the code for putting in these coordinates to go home, essentially. So these are some numbers I inferred from either measuring it or from the star mapping or from figuring out where it is based on the Pentakis dodecahedron. So just as a couple of the constellations that surround the target that we zoomed in on, and built some codes for just figuring out which one's closest. So the little left pony, I guess, little pony is the closest coordinate. And then we can plot just visualize the stars and the faces of the stars to see where the point is in red, and then sort of the points, these different constellations that I just symbolized with numbers here. Because then what we want to do is not only calculate the center, essentially, of the constellation. So there's the L Pony constellation. So we know the center of it, either from inferring it from the shape or just knowing it from star mapping. But we also want to calculate the vertex for the three vertices of the triangle. So we want to know the north and the southwest and the southeast vertices of the triangle. So we need to like kind of know the positions of the other constellations to help us just figure that out. And that's where you just kind of do a little bit of math to try to find the vertices. And so there's also like two functions I used over and over. So basically I have this transformation function to tell me, like, if I give it a vertex in three-dimensional space on the surface of the sphere, I want to know where would that be relative to a particular triangle. So if I know the way the triangle faces based on these two vectors, I can do this calculation in the center of the triangle, basically, yes. And I can do this calculation to then reorient the value of the vertex into a reference frame that sort of looks like this triangle. And so since these triangle faces can kind of point in different directions on the sphere, you need this function to just orient the triangle. And then I built another function to, given the vertices of the triangle and the center point, to just essentially try to draw, this triangle, this second secret triangle. So those functions are used over and over, and then the point is to like take the coordinates of some of the constellations and combine them in different ways to calculate the vertices of the triangle. So essentially the ones around the left pony triangle here is sort of like the average of all 5 of these, or sort of like it's like right in between these two and right in between these two. So if we just combine those different vector coordinates and normalize them, we'll get the coordinates of the triangle. And we also want to just find the orientation of the triangle. So we have these vectors that sort of point from the middle to the top and from the left to the right. And then we can also create the projection of the coordinate onto this triangle, right? So here, down here, now I've drawn the triangle with L Pony in the center, and the coordinate of the target destination is still the red dot. And we can see that it kind of falls in this triangle that points up. So our next coordinate in this system is up. So what we would then do is place the pony in the first slot, then place the up in the second slot, and then have zeros everywhere, and then measure the next center of the next triangle. And although you could kind of technically count, I found it a little bit difficult because so there's L Pony. Well, especially on the first triangle, it's on a sphere. It's still technically on a sphere. So like it didn't quite compensate for that. I lost it. And so if you're a little bit off in the coordinates, it ends up being like so precise. You can't just like get away with an approximation. So it's a bit tricky to make sure that you're in the right place by just purely calculating it. So instead, sometimes I would try to calculate it, but then you would get off a little bit. And then you have to resort to like what I call measuring the value. So that means measuring the value just means putting in the coordinate system into the gate and turning it on and activating it and writing down then the number that corresponds to the output of the gate. And so if I was a little bit unsure of the calculation or started to seem off, I would have to do some measurements to then figure out like what the next coordinate would be. And then what you do then is just hone in more and more of the triangle. So what we then want to figure out is then, so we have a pretty good idea that the dot is in the triangle with the up symbol now. And so we want to then figure out the 3 coordinates around the triangle, the 3 vertices around the triangle. So basically I would just compute from some of the other vertices we knew before, the values. And so since it's like way up here at the top, like it's the same exact vertex as before to the north, and then I just sort of did some multiplication of some vector algebra, vector combinations. So it's 7/8 of the way from between north and southwest, and 7/8 of the way between north and southeast. So that gives us a new vertex, and we can then zoom in to the next triangle. So again, we would zoom in to the next triangle, plot, and try and figure out where it was. But here, since we sort of calculated the triangle directly, it gets off a little bit. So like sometimes, like I'm saying, it becomes so precise that like any mistakes or slight inaccuracies can make it off. But then what you do is just measure more constellations using the gate. And so this time I wasn't sure if it was between newer plus here, Walker plus and Bucket. Oh yeah, Bucket. So these are all the names of constellations. But then I measured these exact values, and then you can do some more calculations to figure out like what the vertices are. And so there was a length between the U and the plus here is a really important length, and it's actually the same distance between the centers of these 2 triangles that are facing each other back to back, north to south, as it is between the center of the U to the, well, I call this the north vertex typically, but no, it's pointing south, but it's upside down. And then, of course, the length between the neighboring triangles is the length of the face up here. And so basically you can calculate these lengths, calculate the vectors for east and west and north, and then figure out some combinations of these vectors to find the vertices of the triangles, do the transformation, and plot the lines. And then you can see actually that indeed the red dot falls into the U, which I believe is the Bucket constellation. And the Bucket constellation is, which one is the Bucket constellation? Just for a reminder, we can look at the thing over here, and I think the Bucket constellation is this one right here. So let's go find it. Bucket. Spiders, please go away. Your dead bodies, go away, please. And of course, yes, it is sort of hard to find them. And where are you? Darn it, don't see it. Is this it? No. Bucket. There it is. There it is. Here we go. So Bucket is then the 3rd coordinate. So we gotta rotate the thing to the 3rd position. Bum, 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 bum. Cool. Okay, and then our power goes up to 40 gigawatts, of course. Yes. All right, and then we do it again. We just keep doing this till we find the dot precisely. And so then, but then see the triangle here is upside down, so we have to sometimes worry about the triangle flipping. So again, and sometimes the vectors will flip north or south, and yep, or well, you can tell when the triangle's upside down, but sometimes it also flips left to right. It's hard to tell. So sometimes you just have to make the vectors negative or not, and then again, we just want to plot the next triangle and see where the red dot lands, and in the next face, it lands way over here on the right. So then our next coordinate system is right, and we then do again some calculations to figure out the vertices and plot the little triangle afterwards. So our next little symbol we're looking for is the right direction. That's the left direction. And there's the right direction. So we move this one over to the fourth coordinate. Boom, boom, boom. All right, we're getting there. So now we're just going to basically punch in the code, since I did all the work of figuring it out already. But I don't know what happens. I mean, I know a portal opens, but I stopped there. It's going to be a surprise. Okay, so then we zoom into the next triangle. It's kind of right in the middle. Right in the middle means it is then this zero signal. So where is now the zero signal? There it is, pretty close to where we want it to be. So we rotate this in a little bit further. Stop. Too far. Okay, the zero signal is now in the coordinate. It's in the spot. Zoom in again. Find the... See now, like we're zoomed in so much, it's like any imprecision messes you up. So do a couple more measurements, measure the lengths between a couple of triangle faces, and then we have, figure out exactly which triangle to look at and zoom in yet again. So the next face is the alien E, it looks like. I think so, right? Just checking. Alien E, I think we decided on. Yes. Okay, so let's go find alien E here. And yes, I had to also do a lot of measurements to figure out the temple coordinate, the triangle coordinate map. So like you can tell from the temples, but yeah, you can also put the entire jigsaw puzzle together from only like not that many temples, but hey, we finished finding productivity. Or yes, but every constellation is unique in terms of its location on the triangle, so you can't really tell exactly. You can't tell from the puzzle, but you can tell by then just measuring the different values and guessing. And so a couple times I didn't know that this symbol was in this triangle, or didn't know the right symbol here, so I would have to guess a lot. And eventually, though, I found most of the map of the triangles. I think there's a couple of spots I never looked up because I found the spot I was looking for before I needed to, but I had to search through lots and lots of measurements to map out the entire face of the triangle as well. And then we zoomed in again after the alien E, figured out which way is up and which way is left. And then we see that the dot is down here by the U. This is the upsilon, I think. And then eventually we zoomed in one more time. Finally found the bottom of the triangle where we see that the target location is exactly then the upsilon and the dagger. So that's all that's left to do, is put in the upsilon and the dagger. I call it upsilon because it looks like it got accidentally stabbed. It's a U. I got stabbed. All right, where are you? Well, there's the dagger, so we can put that in the Final location right here. Call that the dagger. I hope I call that one the dagger. I think so. Right. Let me just double check here. Yeah, that one. Okay, and oops, the one is there. There you go. There it is. So roll it into the final location. Here we go. Here we go. Gate victory on the verge. Hopefully I did it right. Okay, before I press the button, let me just double check one more time. And this is the U, and from the picture, it's this, right? It's the H bar, the U. Okay, oops on. Here we go. Okay, so let's see what happens. Oops. I guess I didn't do it. I didn't actually put the dagger in. Where'd it go? There it is. All right. Well, there we go. Put it in order anyway. Dagger. The gate opens. What's going to happen? Analysis distortion vector 566 -8.28 0.272. The portal is stable and leads to your final destination. Enter the portal to win the game. All right, there you go. Ancient gate victory. Space exploration. Yes, indeed. Man, this is maybe take a screenshot of this one. Cool. Well, looks good. We did it. Entered the gate, won the game. Analysis of a gate victory. We got the gate victory. Man, but yeah, it was tough to figure out this puzzle for sure. I definitely spent a lot of time putting in the wrong coordinate system. I have a whole nother notebook over here with lots of mistakes and measurements and trying to figure things out and measuring. Lots and lots of measurements. Just doing calculations, trying to visualize the 3D shape. Lots of experiments. So all of these, all these circles are mistakes. I essentially tried different experiments. I was trying to figure out like what to put in and what was happening with the numbers. And I was kind of trying to triangulate the point at first. Sort of like, I was thinking that like you kind of saw like the triangulation to create this pattern. I was trying to do something like that, but did a lot of experiments and realized that that couldn't be right. It had to be some sort of combination kind of thing, and eventually, yeah, I definitely needed some help from Reddit, but yeah, there wasn't really much out there. There's very little out there in terms of how to actually activate the gate, but now, well, there'll be this video, I think, and let's see what happened to the exploration journal. Ancient Gate Victory. The huge ring artifact, an ancient intergalactic gate, was eventually repaired to the best of my ability. With some heavy jury rigging and ingenuity, I finally managed to get it working. I anchored the distortion field to the local stars, decoded the non-numeric glyph coordinate system, and reverse engineered the dialing system. My mind feels warped by such alien concepts, but it works, and I finally made a portal home, a trip home to a galaxy far, far away. It took but a moment. Leave behind an autonomous interstellar empire, built from the ground up by my own hand. My legacy in this space will live on. Ha ha ha. Well, yes. Well, yeah, there we go. That is then the end of the Space Lavar Exploration series. And man, what a journey, what a ride. I think, yes, we'll just have to call the session here. Thanks everyone so much for following along, and it's been fun doing the YouTube, just learning a lot, and learning a lot of video editing and how to talk, and man, it's been an interesting experience, yeah, but we did it, we conquered space exploration, we opened the gate. Man, thanks again, Irindel. Space exploration, it's very incredible. Just, I mean, how do you come up with this? How do you come up with a 10 pentakis dodecahedron triangle 3-dimensional coordinate system symbols? Man, boy oh boy, but wow, cool. Yeah, so this will then pretty much conclude, I think, the space exploration playthrough. There you go, Factorio. I am Pax. I'll see you. I'll see you next time.